Hi, this is Austin with Radical STEM Tutoring, and today we're going to do some physics using kinematic equations. So if we're on a roller coaster that starts at rest, the initial velocity will equal 0 meters per second. It accelerates at 15 meters per second squared for a duration of 5 seconds. Then how far are we going to travel? The final distance, what will that equal? And how fast will we be going? The final velocity will equal what? Alright, let's get started. Now to solve this, we're going to use our kinematic equations. The one we'll be using today gets us the final position, x final, using the initial position, the initial velocity, times the length of time that we travel, plus half of our acceleration, times the time squared. So, we have some of these. X initial is 0, so when we rewrite this on the next line, we can say that x initial is 0, plus v initial is 0, so that's 0 times our time of 5 seconds. That won't really matter since it will just equal 0, plus 1/2. Our acceleration is given to us, 15 meters per second squared, and then the time squared, 5 squared. So obviously, these two 0 terms are just going to vanish. So on our next line, all we're going to have left is this. So that's 1/2 of 15 times 5 squared is 25. So if we put that in our calculator, that comes out to 187.5 meters. Now, how are we going to find the final velocity? Well, we'll have to use a different kinematic equation, but if you know a little calculus, you can actually get to that one by taking the derivative of this equation. Now, if you don't know any calculus, if you're in high school physics, that's okay. Just follow along and you can remember the end result. So, if we take the derivative with respect to time of this x final, now notice that this is actually a function with respect to t. So we can take the derivative of this function, and the derivative of the function position is actually defined to be the velocity. This is going to be a function for our final velocity, the function of time. So this will equal the derivative of everything on this side. Okay, so the derivative of the constant xi is 0, so we won't even write that. Right here, v initial times t, that's just a constant times t, so the t goes away and we're left with v initial. Now, 1/2, that constant will stay out in front, a will stay there. Use our power rule on this t to bring the exponent down. So we'll have a 2, and then our exponent 2 gets reduced to 1, so t to the first power. And then if we just simplify that a little bit, the 2 and the 1/2 will cancel out. So v final just equals v initial plus a times t, and that's what we're going to use to find our final velocity. So if we go ahead and plug in our numbers, remember our initial velocity is 0, so it's really just going to be a times t. 15 meters per second squared times 5 seconds, and that is going to give us 75 meters per second. Now what if we wanted to investigate a roller coaster at another theme park? Here, we knew the acceleration and found the final velocity. What if all we knew was the final velocity, and we needed to learn the acceleration? So let's say this other roller coaster gets to a final velocity of 100 meters per second after 5 seconds of acceleration. How could we solve for that acceleration? Well, we're going to use the result of taking our derivative on that kinematic equation. That was the final velocity equals the initial velocity plus a times t. So if we plug in the numbers that we have, that's 100 equals 0, so I won't write that, a times 5. And then we just have one step, divide both sides by 5 to get that a equals 20 meters per second squared. I hope you guys found today's video helpful. If you did, be sure to like and share the video, and have a great day.